So here we're asked, what is the mass percent of each element in copper 2 nitrate, which is CuNO3 twice? So we've already talked about molecular weights and how to calculate them, and we're going to need the molecular weight to solve this problem. So we're going to assume that we have 1 mole of CuNO3 twice. So if we have 1 mole, we needed to figure out how many grams of each species, or how many grams this mole is going to weigh. So in terms of copper, there's 1 copper atom in this complex, and we know that that's going to have a molar mass of 63.5 grams. So we have 63.5 grams coming from the copper. In the nitrogen, we have NO3 twice. So there's going to be 2 nitrogens times 14.0 grams. That's going to give us 28.0 grams. The oxygens, there's 3 times 2, or 6 total, times 16.0 grams, is going to give us a mass of 96.0 grams. So for every 1 mole of copper 2 nitrate, we are going to have 187.5 grams. So now we can use the mass percent, and our formula for mass percent is going to equal the mass of X divided by the total mass. Then we need to take this decimal and multiply by 100%. So our mass percent of copper is going to equal 63.5 grams of copper divided by our total mass, which is 187.5 grams, times 100%. This gives us 33.9% copper. Our mass percent of nitrogen is going to equal 28.0 grams of nitrogen divided by the total mass, which is again 187.5. We multiply by 100%, and that gives us 14.9% nitrogen. The mass percent of oxygen is going to equal 96.0 grams divided by 187.5 times 100%. This is going to give us 51.2% oxygen. And as a double check, we can add all these together and they should add up to 100%. And then in this case, they do. So to kind of recap, if you're ever asked to determine the mass percent of each element in a particular complex, assume you have 1 mole of the substance, calculate its molar mass. Then to get the mass percent, you take mass of the component X divided by the total mass. So we take the mass of the copper, the nitrogen, and the oxygen, respectively, in each case, divide them by the total mass, or the molar mass, of the entire compound, multiply each of those by 100%, and that will give you the percents that are listed here on the right.